Now, another advantage of using a database like Cosmos DB is this concept of consistency. So if you go into settings under default consistency, we can see that the session consistency is the default. Now there are 5 choices to choose from. I do like this image or this animation that Microsoft has that explains what consistency looks like. So if we start on the left with strong consistency, it's basically guaranteed that when a region writes a piece of data, that all of the other replicated regions are able to read that data at the exact same moment. So in some sense, there's a delay in the writing such that the data gets replicated to all regions and then it's available to everyone. Okay, so we've got a perfect consistency across all the regions. The Canada East isn't going to read the data and be a little bit behind something that was written or another region has access to. There's a concept of bounded staleness here. And we can see that the data is going to be consistent. You see it's being deployed in the colors of the notes here are coming out in the same order. But you can define the maximum lag time. So maximum lag is here. And the note says that it is minimum of 5 seconds for a single region and 5 minutes for multiple regions, up to 1 day. So if you said, you know what, I'm okay with there being a 5-minute delay between the time that I write and the time that's available in all the regions, then you can use this bounded staleness. And we can see here the data is being written and it gets a little bit of a delay in terms of the data being available in other regions. Okay. Now session is the default, and basically what it allows is that depending on the session of the user, that person's going to get consistency. So in session A, they can write here and then read in another region, and they're going to have consistency because they're reading from the same session. Whereas another session, another client in a different region will see the same data, but basically it's going to be consistent, but there's going to be an undefined delay between each of them. Okay, so this is a little bit confusing in terms of the type of consistency model, but basically the same client, the same application could access the data in 3 regions in this case, and they'll have the same data read in A, B, and C all returns the same result, whereas a different client might get a little bit of an earlier result. Coming up next is called consistent prefix. And basically it says it's basically going to be always displayed in the right order, but we can see that there's a definite lag between the time it's written and when any particular region has it available for writing. But there is a guarantee that the data updates will always come in the right order. It's going to be A, B, A, B, C, but it'll never be B, A, C in terms of updates. Everything's guaranteed in the order, but there's really no guarantee as to when a particular region gets the next update. Now, eventual consistency is called the weakest one, and in this case, there's just no guarantee that they're going to come in the right order. So this is for the type of data where it doesn't matter what order they come in. Microsoft gives the example of retweets, likes, comments that are not in a threaded fashion. So anything where it doesn't matter that A was before B, as long as A and B eventually get displayed, then this is the kind of data model you would choose for this. So if you really do require that if you're going to write to the database and every region of the world that your database is deployed to has that data available at the exact same instant, then you're probably going to get pulled towards strong consistency. If you're fine with a little bit of a lag, some data gets written in Canada, but it takes a few seconds to get to Australia and maybe another few seconds to get to Europe, then you would choose something like this, right? Of course, you don't want the same client to read one piece of data in one database and read a different piece of data in a different database And so maybe session consistency is best when it's bound to the client. So for the exam, it probably would be smart to review these types of consistencies and understand under what circumstances you would choose a strong consistency, what circumstances you would choose a session consistency, and maybe what circumstances are best for something like an eventual consistency where the order of the data doesn't matter as long as you have the sum total of the data, right? So hopefully that makes sense in terms of consistency, which is one option that you have for Cosmos DB that you don't have for a table storage account, for instance.